So just talking a little bit about the SF6 technique. There's several of you in the room who have used it and are probably much more familiar with the technology than myself. But for those of you that this is new concept, so SF6 stands for sulfa hexafluoride, and that's going to be the tracer gas that's used in this application. SF6 is a biologically inert, so that's why we can release that into the rumen. It is a greenhouse gas in itself, so some negative connotations with this methodology. It's a little ironic that we're using it to try to come up with methods to reduce greenhouse gas emissions. But in a nutshell, you're going to use a permeation tube or a bolus, and that's going to be what's inserted in the animal with that SF6 gas, and that's going to be used as a tracer for the animal's methane emissions. Before you put that bolus in the animal, you'll have to do a lot of weighing to determine what that release rate is, putting it in, a warm vat of water to mimic the rumen environment. And then I see Ralph nodding his head. Ralph or Pablo, if you guys have anything to add here, by all means, you would typically weigh it daily to figure out what that release rate is. And then obviously these animals need to be used to being handled and halter broke. So it's a pretty labor intensive way to measure methane emissions, but it does work really well, and you can get really low, coefficient of variation, and it's a technology that can be used in grazing systems versus, respiration chambers. Obviously that wouldn't work for grazing cattle. Just talking about a few of the other alternative methods, of course, respiration chambers are always going to be really important for this kind of research. They are the true gold standard, being that we're measuring 100% of emissions from that animal. The downside when we're putting animals in a chamber like shown there at the top of the slide, this is a full chamber, and then they also have just head chamber systems. This is from UC Davis. The animals can lie down in here, but they're being removed from their home environment, so intake is often significantly impacted in these chambers. If animals aren't eating to the extent that they normally would be, their methane emission patterns are not going to be normally reflected. They're really low throughput, and again, really costly to have a different or a respiration chamber system like this. In vitro systems are going to be great for initial, screening of feed additives, but the animal model is always the best model. The face mask technique here, again, it's going to work well, but obviously animal handling required. You have to run that animal physically through the chute, really low throughput. So depending on what your specific goals are with measuring emissions, you might be more interested in some of these technologies than the other. For metabolism trials where you're collecting total feces and urine, respiration chambers typically work well for stuff like that. You're already handling those animals anyways. If you want to be doing rapid phenotyping and collecting as many measurements as possible, you're going to be looking for a tool like GreenFeed. Sniffers are getting some traction as well for phenotyping, and we'll talk tomorrow about why I caution anyone using sniffers for phenotyping. Also, handheld lasers are another one that's becoming popular. So that's different than a sniffer, and that it is just that handheld device. But again, lots of problems with those measurements when it comes to repeatability, quite a few random errors. And last but not least, another technology is portable accumulation chambers. These are only going to really work for smaller ruminants, but they're being used pretty heavily in New Zealand and in parts of Europe. I think there's a couple pack chambers in Scotland currently. But these are going to be, it's a 12 stall trailer, 12 little chambers on this trailer, I should clarify, and they would come onto your farm, and this is really going to be designed for phenotyping animals. So you'd put a sheep in one of those small crates, and then you're just accumulating, again, all of the emissions from that. I was able to see these in actually New Zealand last month, and it is a problem if they have some really big ewes. They said they did have to let them out of the chamber due to CO2 levels getting too high in there. So that's something that you have to be mindful of, the size of the animals, which is why this technology doesn't transfer well to cattle. You would have to have a massive, chamber for a lactating Holstein animal, for example, and then at that point it's not going to be portable anymore. But these do work pretty well for, like I said, those smaller lambs. Has anybody seen pack chambers or used pack chambers at all? In New Zealand in particular, their government was offering a phenotyping incentive program where you could come and get a lamb phenotyped for $45 a head using these. And then they had been maintaining some divergent, high and low methane emission lines for the last 10 years. So all of that being said, those other methods all really lack standardization. They are good in their own regards, like Pablo said, on the SF6, it works really well, but every lab has kind of their own way of doing it. Similarly with respiration chambers, every chamber has a little bit different ducting efficiency, different ways that they take those samples, whether it's every 7 minutes, every 10 minutes, etc. Versus with GreenFeed, all of our systems are going to be operating the same way. So we have those standardized machines, that when the air filter is clean, that should be 40 liters per second airflow through there. We have the same data processing because we do all that. It's not left to the client. It makes these data sets that are directly comparable worldwide. The certified calibration gases are another thing. That's a program that we implemented in 2018. So we have a calibration gas standard here at CLOC, and any gas tanks that are purchased from CLOC are compared against that global standard. And the reason we implemented that is we found a lot of the certificates that you get from your local gas supplier, they do have errors in them. Just the mix of the span, which when we're using that to, of course, calibrate the GreenFeed sensors, we need to know exactly what is in those span mixes. We further have automated the process for recovery. So new GreenFeed units are equipped with an auto recovery system on them. We'll talk a little bit about auto calibration and auto recovery in the next couple sessions this morning. And then the continuous monitoring is, I think, a really big thing. So all green feeds out in the field have 24/7 monitoring done on them. We have automated flags that will pop if there's something that's noted, but then also, real data analysts that are consistently reviewing your calibration results. They're consistently reviewing the results of the manual CO2 recoveries. So oversight, if you have any kind of problems, we're here to help hopefully catch them before it would be impacting your experiment is our ultimate goal. And then I mentioned this earlier, you can measure animals in any environment. So, grazing animals are 80-90% of the total cattle population. So I think it's really important that we're able to measure in those extensive systems, which is something that GreenFeed allows you to do. This is comparing some data from respiration chambers. Early on when GreenFeed was first introduced, it was a hard concept for people to accept that you could just do these spot samples throughout the day and have it be able to accurately reflect methane emissions, because in chambers, we're continuously monitoring that animal. It might be in the chamber for 24 to 48 hours. So you're capturing all the emissions over that time frame, versus an animal may only visit GreenFeed, let's say 3 times in a 24-hour period. So this was a meta-analysis that was done in 2019 by Hutton et al. And they were comparing, there were 6 different studies at that time. There's some more that have been published since, but any studies that directly compared the same animals on GreenFeed and respiration chambers. And then some of those studies had multiple group means. So that's what the different points on this graph denote. I apologize, my x-axis here isn't labeled, but that would be GreenFeed grams per day versus we're looking at the methane grams per day on the y-axis. And when we regress those two measurements, the r squared there is 0.92. So that shows really strong agreement between chambers and GreenFeed. And another study here from Christov, he reported the typical coefficient of variation for respiration chambers at 30%, GreenFeed at 18%, and SF6 at 28%. What's interesting here to myself is that the coefficient of variation for GreenFeed was so much less than respiration chambers, and that's attributed to the animals that are in the chambers. Some are more affected dropping their intake than others, so that creates a lot of variation in the methane measurements of that group versus with GreenFeed, because they're measured in their home pen, they're all eating uniformly, routinely, and so that's shown in those coefficient of variation. There was an additional study here that early on in 2015, Hammond published a study comparing GreenFeed to respiration chambers and found pretty poor correlations between the two. But I want to note that he only used 4 animals in that study, so probably some sample size issues. I mentioned earlier that respiration chambers are variable. So this was a study that was done in 2015. And it was done in the UK, and then they evaluated 22 different respiration chambers across 6 different facilities. So think university facilities, some of them maybe have, 4, 8 chambers on site. And then they evaluated, did recoveries in all their chambers, looked at all the total efficiency, and they found that across those 22 chambers, the uncertainty was around 26%. So again, respiration chambers are really thought of as being great, this golden standard, but when it comes to comparing your respiration chamber data to Liège's respiration chamber data, they don't always line up as nicely as we would like them to. This is from the same meta-analysis from Hutton. And they looked at these 18 different equations that were developed to predict methane emissions. So these equations, of course, have, predictors like animal factors, predictors, NDF, diet composition, etc. And all of these equations were developed using empirical respiration chamber data. And then they used those to predict methane emissions from GreenFeed, and they predicted really well is the moral of the story. So the average root mean square prediction error was 11.2%. They ended up excluding a few equations for outliers and ended up with that 6.2%. So really strong agreement between GreenFeed data and predicted methane as well.